Hello, data analyst. Welcome to week 6 project class. Today, we are solving a critical real-world problem. Our logistic partner experienced a 12% failure rate in holiday shipment in last Q4, resulting in $4.8 million in penalties. The challenge? They couldn't pinpoint which vendor were responsible for these delays. So in this comprehensive class, we'll build a complete SQL analysis from scratch using Postgres. We'll identify the worst performing vendors. We'll calculate exact penalty cost. And in the end, present our findings. Because of the depth of the query, the length of the query as well, we wouldn't be writing in class. I'll be showing you what we have done already and discussing them in detail so that we can pay more attention to discussing them and explaining them in clear details. Okay? So let's begin by creating our database. We'll right click on databases, click create, click database. So let's call our database logistics DB. We'll go ahead and save. Okay, so we've created that database. All right. So now we have written queries for the tables we want to create. Okay, so we are going to click on the query tool so that we write those queries here. All right. Okay. So like I said earlier, we have already written the queries that we will need so that we don't spend much time or all of the time writing the queries, but focus more on explaining what these queries do. Okay, so the first table we will create is the vendors table. So I have this written on my notepad here, so I'll copy this and let's go to our query tool here and paste it. And then I can explain what this does. Okay, so in our previous SQL classes, we had created tables already. So the create table function isn't new to us. And what vendor stands here is not new to us. Well, or what vendor means here is not new to us. That is to say, we are creating a vendors table. Okay. And I know these data types are not also new to us, but I'll just refresh it, basically like refreshing our memories. So we are creating a vendors table here with the following columns: vendor ID, vendor name, contract terms, service level agreements, operating regions, subcontractor allowed, primary contact email, contract start date, and contract end date. Okay, so we will not be imputing this data manually. We already have the data in a comma delimited file, in a CSV file that we'll be importing into our database here. Okay, so let's take a look, right, at that file and see if our columns are matching appropriately. All right, so let us have a vendors table by the side so that we can look at our column headers. Now we have the CSV file to upload. We have vendor ID matching the query we are writing. We have vendor name, contract terms. Okay, let's look around and see what we have. Okay, this is matching as well. Subcontractor allowed. You can see we have it there. Then we have primary contact email, the contract start date, and the contract end date. Okay, so now we have every detail here correct. Okay, the next thing to really look at so that you don't have any issue importing your data is the data type. For the vendor ID, we have integers. This is correct. Then for the vendor name, we have varchar set at 100. Okay, so the varchar here holds text field, right? And the 100 there indicates that it is limited to 100 characters. We can use it to store names, email, zip codes, and so on. Anything that we must present as text, okay? Now, remember the constraint not null. We want to use not null to prevent null value being uploaded to our databases, okay? Then in the contract terms is text. The difference between text here or varchar and text here is that text contains unlimited length of text. Okay, so it has no limits. Okay. In the service level agreement, you can see the service level agreement here is numbers. So we use decimal and we give the size of 5 and we just give a decimal point of 2. Okay, say 2 decimal places. Okay, then we have operating region, which is varchar as well, set at 100 to limit the number of characters to be entered. Then there's something new here. We use something new that we have not used before, and that is called an array. Okay, this here is called an array. It contains a list of items like a box of states, right? It is useful when one row can have many values. And let's see our data set here or our table in Excel here and see if that is true. Our operating region here, you see that we have values, okay, that are not in their singular form. That is, we don't have single values like we have elsewhere. We have values in arrays. So that is why we used this array. Okay. So all of that are things we have done before. So let us go ahead and execute this query. Okay. Okay. So let's highlight and execute it. So we have created that table successfully. Okay. So we can go ahead now and import our data into the table we have created. Okay. We remember that we can use the select all to look at the table we have created and say, we say it's vendors and we say it is vendors table, right? Okay. So let us execute this and see the vendors table we have created. Okay. Now what is left is to copy our data into this table. So this is our database logistics DB. Let's expand our schema, then go to our table, and we can see our vendors table. We will right click and click on import to import our vendors data. Okay. All right. So let's click on the vendors on the table, which is vendors we want to import. Click on open. Go to options and let's see everything is good here because header must be checked. It is comma delimited. Okay. So we can click OK to begin the import. We have successfully imported that table. Okay. So if we look at the table again this time, we'll see that we have truly imported our data. So let's move on to the next table. Okay. So this time is the shipment table. We'll copy the query of the shipment table. Okay. And let's paste it here. So from our previous classes, we had talked about the use of timestamps, as well as primary key and references. So this is not new, right? Because here in the shipment table, we are creating a column called shipment ID, and the shipment ID is the primary key for this shipment table. If you go to the vendor table we created earlier, we see that we had the vendor ID, which was the primary key of these vendors table. So the references here connect the shipment table from the vendor's ID in the shipment table to the vendor's ID in where? In the vendor's table. So here in the shipment table, vendor's ID is the foreign key. Whereas in the vendor's table, the vendor's ID is the what? Primary key. Then the check here just gives us a check because we want to check that priority level is actually between 1 and 3. And if we look at this table in the data set, let's say the shipments table, right? We have it in the comma delimited file open here. If we look at the priority level, let's check that the priority level. This is a priority level column. If we look at the priority level, you see that the priority level is actually between 1 and 3. So we just wanted to create that check to ensure that our priority level is actually what it is, actually between 1 and 3. Then the service type column, which will hold a voucher, that is a text with a limited number of characters of 20 or characters of 20, will have items, right? That is the use of this check, you see. We'll have items like what? Ground, express, overnight, international, okay? Basically, to create a constraint around what is going to be imported, right? For instance, if we have a value that doesn't correspond to any of these, we are going to have issues importing them, more like we are creating or validating the data that should be led into our database. Finally, we have a constraint here that constrains the column valid delivery and checks if valid delivery is null or actual departure is less than or equal to actual delivery, whether the actual delivery is null or actual departure, which is a column, is less than or equal to actual delivery. Let us look at that, this part of our data set. Okay, for the delivery to be valid, right? Either of these two must be done. Actual delivery must not be null, or actual departure must be less than or equal to actual delivery. So let's look at our shipments table again. You can see the actual delivery, okay? Now this is actual departure. Basically, what this shows is that it doesn't make sense if the actual delivery date is earlier than the actual departure date. It doesn't make sense because a product or a package that is yet to leave cannot be delivered. Okay, so that is why we put those constraints there. Okay, so let's go ahead now and execute this query to create this table. Okay, you can execute. We have done that. So the table name is what? Shipments. Okay. So let us look at the structure of that shipments table. Let's see that table. Okay. We have successfully created that table. So what is left is to populate this table with the data that we were presented for analysis. So we'll refresh our table. So we now have our shipments table. Right click on that table and let us import. Let's pick the shipments dataset, click on open. Let's look around to see if everything is good. It's comma delimited. The header option is on. So we click OK and we successfully copy our data. Okay, so let us see our populated table again. Now we have our populated table. So let us go on to the third table. And the third table will be the penalties table. Let's copy for the penalties table and go ahead and discuss it. So for the penalties table, now you are professionals already. So will there be need to still talk about a create table? In any case, let me just say something about it. So we are just saying, hey, SQL, I want to make a new table with this comment here, say create table with this function rather, they create, we are saying, hey, SQL, I want to create a table. And I want to create a table called what? Penalties, okay? Now, the table will have the following column headings, penalty ID. And penalty ID is an integer. I want to use penalty ID as a primary key to create a relationship between this table and others. So the other column is the shipment ID. The shipment ID is what? An integer as well. That is to say, it's the whole number. I'm using references here to do what? To connect this penalty table to the shipment table via the shipment ID. That is the shipment table we created earlier. So in the penalty table, shipment ID is the foreign key, whereas in the shipment table, that shipment ID is the what? Primary key. Let's talk about this grace period. And remember, we had talked about what a Boolean is. The Boolean is true or false. So why do we use this default false? Using default false to explain that when no data is inserted into grace period, let it default to false. For instance, instead of using not null, we use default so that even while data is entered, when there is a null value, let the null value default to false. Then to the last column of this table, the access date column, we are indicating that the column should have timestamps, that is timestamps with time zones as the data type. And we are defaulting this to current timestamp. That is to say that the timestamp that the column is accessed should be the default timestamp, assuming no timestamp is entered. Assuming no time is entered, let's execute this query to create table, okay? All right, we've successfully done that. Shall we look at the table we just created? So to select all from penalties, okay, we close the query and go ahead and execute to see our table, much like our table header, the skeleton of our table without the data yet. So we are going to refresh this table, see our shipment or our penalty table, okay? As usual, let us import our data into the penalties table we created, okay? So click open, let us look around and see, okay, everything is good, it's good. So let's click OK to have that imported. We have imported that. To execute now, we have a table, okay? All right, the last table we will create this class, and that table is going to be the vendor capacity table, which will be the table that we will be using to track capacity of vendors. So just paste this and discuss it a little bit before we go ahead and execute. If we look at this now, it's not different from what we have been discussing. Like I said, the secret here is to understand your data set and understand what you want to achieve. Then with that, it is quite simple because we are creating a table called vendor capacity. The table have the following header: the record ID, vendor ID, date, daily capacity, utilized capacity, right? So now the unique here is used to say what? We want to ensure that the vendor ID is actually unique and not repeated values, as well as the date here as well. We don't want repeated dates. So let us execute this and we go ahead. We have successfully executed that. We are copying data into the last table we created, which is vendor capacity, right? So right click on that table. Let's go to import and the file from which we are copying our data, which is vendor capacity. Click open. Let's just basically look around as we've been doing earlier. Click OK to import our data or copy our data into our table. Since we have successfully done that and the process is complete, let us look at that table one more time. You see now we have everything within the table properly copied. So we have created this. Usually, we create an entity relationship diagram and ERD to check our relationship and basically see how our tables are related. With these queries now, we cannot actually see how our tables are related, or we can basically see the models of our table as objects, right? But we can do so using ERDs. In this situation now, you can create your ERDs directly before you even go ahead to do anything, right? Like for instance, under tools, you can click on ERD tool and then you manually create your relationship or your table before creating your relationship, right? You can click the plus to add tables and keep adding columns upon columns upon columns manually. But in our case, we have already written our queries, connected or created our relationships between the tables we have created. So to automatically create our ERDs, we will right click on our database. That is a database where we have our tables. Then click on ERD for database. So you are going to have the entity relationship diagrams for all of the tables you have created within that database. To ensure that tables you create within that database are tables you actually want to have your ERDs for, okay? So if we move this around, you are going to see what we have created so far, the tables we have created, and the relationships that are within them, or how they are related. Okay. This ERD gives us a clear picture of our tables, the columns in our tables, and the data types. Let's look clearly at our shipment table. So let's zoom. So you can see that our shipment ID here is an integer as we wrote in the queries, right? And is the primary key. You can see here our vendor's ID is also an integer. Origin zip is what? In character, that is varchar, varying in 10 characters, right? This is the size of it. So varying character, right? Basically, that is what varchar means, character varying, okay? So this ERD gives us a clear picture of the relationship between our table. And in our case, we are looking at operational logistics, right? So behind every delayed delivery is a story, and this database tells that story. The schema you are looking at is a classic example of a normalized operational system used in logistics and shipping companies like FedEx, DHL, and Amazon. It is built for accuracy, accountability, and auditability. Now, let us look at the relationship, right? We said the ERD helps us put the relationship in a format that is visual for us to see, right? Instead of just as we had in the queries here, okay? Instead of what we had here, the reference, right? Wherever we had the reference within the tables, okay? Now, we have one vendor to many shipments based on our vendors or the relationship from our vendors table to our shipments table, okay? Now, each vendor is responsible for multiple shipments. This is a one-to-many relationship from vendors to shipments. We also have one vendor to many vendor capacity records, right? I believe you can say it. One vendor to many vendor capacity records. So each vendor has a daily capacity record. The vendor capacity table shows how much work a vendor could handle. This is another one-to-many relationship from vendor to vendor capacity. That is from vendor to vendor capacity. Okay, so we have another one shipment to many penalties. Okay, these are penalty tables. So a single shipment may have multiple penalties due to delays, custom issues, etc. So shipments links toward penalties. We have an optional subcontractor vendor relationship here where you see we have subcontractor ID. So we look at this now. The subcontractor vendor ID column here in the shipments create a self-referencing optional relationship within the vendor's table. You can see it, right? This is it. It is a self-referencing optional relationship within the vendor's table, meaning one vendor can act as a subcontractor for another, right? And if you take a look at the data set, you see that subcontractor column within the shipments table. You see that vendor one can act as a subcontractor for vendor two, right? When you look at it, you understand basically what we are talking about. This relational structure ensures each business event, like a shipment or a penalty, is linked back to the vendor responsible. It allows analysts to trace problems, measure performance, and suggest improvements, all from plain, well-related data table. This is not just a database design. It is how modern logistic companies hold partners accountable and protect millions in shipping revenue. Before we go on to the next phase, let me quickly show us something here. So we can decide to pick how our cardinality notation will be. We can use the chain notation, right? And we can use the crossfoot notation, which is the default notation we use here. So you can also hide the details of your table. You can decide to hide or show them. Okay, so now that we have basically explained this, let us go to or look at the first analysis we are to perform today, which will be the vendor's performance scoring. Okay, so we'll be heading back to our query tool where we had started writing our queries before. We'll go to our notepad and let's look at the vendor's performance scoring. So see how lengthy the query is, but not to worry. We will discuss this query one step after the other, and so we understand why we are written it this way, and so on. So in our previous SQL classes, I had talked about indenting. And why we ensure that we indent is to ensure we keep our queries clean and understandable, okay? Instead of writing queries all in one line and writing them as if they were text. Secondly, when we go to Python programming or using Python for data analysis, you will understand the importance of indentation, okay? So we have to get used to the best practice of writing code. All right, so let us copy this, okay? And then head back to Postgres and paste this. So we will begin discussing these one step after the other. We have broken down the codes in blocks with comments to even make it easier for us. So let's go ahead and discuss it. But before we go ahead, it's pertinent that we understand what the query in general will do. This query evaluates each vendor's shipping performance during the 2023 holiday season by achieving the following: by counting how many shipments were late, okay, by comparing their actual performance to their contracted service level agreement, by scoring their performance as meets SLA, that is service level agreement, minor miss, major miss, or critical failure. Okay. Then it estimates future penalty based on current trends. Okay. So let us go on and now discuss them one after another. All right, let's start with the first line here. So this first line creates a scratch table, that is a temporary table to calculate performance. And the table is titled vendor performance, right? So then select here is not standing alone. Select helps us pull basic vendor information, as you can see from what vendor ID, vendor name, and service level agreements, all from where the vendor table. In our last class, we talked about using aliases. That is, instead of to say vendors.vendor ID, vendor.vendor name, vendor.service level agreement, we give aliases we could use, okay? Now, this service level agreement will be returned as what? Contracted service level agreement, that is SLA, okay? So let's go on to this line. What will this line do for us? Here, we count all shipments per vendors, and we are using S here to represent or as an alias for our shipment table. Remember that table, right? For our shipment table. And we are counting all shipments per vendor using the what? The shipment ID from the shipment table, okay? And we are presenting this in our new output as what? Total shipments. So now, like I said earlier, we have broken down this query into sections for simplicity, that is to ensure that we can understand them easily. Hence, we use what? Comments. So here, this block will help us do what? Count late shipments, that is excluding grace periods, okay? So we are using sum, which will help us add items or numbers within the column we are going to be referring to. And we want to sum when, so we are using the case when the actual delivery from our shipments table, that is what S.actual delivery means, is greater than what? The scheduled delivery from what? Our shipment table. This condition and the following condition, that is where grace period from our penalties table, that is what we mean by P.grace period apply. equals to false, or grace period applied from our penalty table is null. But we know that we don't have any null value. We had taken care of these when we were creating our tables. That is why we are using the or here. So I want you to remember this. We have used and, right? And indicates that the two conditions or the conditions tested must be true for true to be returned, right? If we use and, if any of the condition fails or is false, our output will be false, okay? So when we use or, we are saying that either of the conditions. So when we say this case and this, we are referring to this and any of what? Of these. That is where grace period applied from our penalties table is equal to false, or where grace period applied from our penalties table is null. So when this happens, what should happen? That is when we say then 1, else 0, and we are going to end this as what? Late shipment. So what happens here? In the case where actual delivery is greater than scheduled delivery, and where grace period applied is equal to false, or where grace period applied is equal to null, if this condition, if this is met, then 1. If not, it will come back as 0 in what? A column that we have given as an alias called what? Late shipment. Okay? So that is what that means. So now let us go to the other block, all still within the query to do what? To determine our vendor performance scoring. So, but now we want to now calculate what? Percentage on time. Here we say 100 minus, that is to say that in a nutshell, basically, we want to calculate the percent of shipments that was delivered on time. So we say 100 minus what? Case when, you see that this exactly is like this. But what happens here is that we want to subtract this from 100 and multiply it by what? 100. So then we go to the next where we do what? We sum penalties. We are going to be using the function or the SQL function here called coalesce. The coalesce function is used to handle null values in database queries by returning the first not null value from a list of expressions or column values. It allows you to provide a default or fallback value when null values are what? Encountered. So in our case now, we will add up penalty amount from our penalty table. If none shows up, it will show 0 instead of null. So that is what this means. And that is why we use the coalesce function. Okay. We want to add up the penalty amount from our penalty tables. And if none shows up, we are going to have 0 instead of having null. And we are going to present that findings in a column called what? Total penalties. And now, remember, when we write queries, we have to indicate from which table we are referring to, isn't it? So that is why we say from vendors. And remember, we said from vendors and we said V. Why we said V? We have not forgotten how we started when we indicated that we want to select certain columns from what? The vendors table. We say join shipments S. Remember, we talked about shipments, right? S indicates what? It was the alias for shipments. And remember I said, instead of using shipments.actual delivery, we could just use S and remember what we have used to refer to that table as the alias of the table. So we'll say join what? Shipments on v.vendor equals s.vendor ID. So what this means is that we are joining shipments on what? The vendor ID from the vendor table where it's equal to vendor ID in the shipment table. So remember, when we use join and we do not indicate whether left join or right join or inner join, it defaults to inner join, right? So we have a left join here now. In the left join, we are linking penalties on shipment ID from the shipment table and shipment ID from the what? Penalty table. So let's look at this block now here. So where we have this, what this means basically is that we want to only look at a final leg, that is where holiday, we have holiday seasons delivery, okay? So that is why we looked at these dates, okay? So from our shipments table, remember we have a column called scheduled delivery. And we use the between to give an interval, right? We use between to do what? To give an interval. And the interval is between these dates and these dates. So that ensures that we actually have a compulsory interval. And what we are saying holiday flag from the shipments table must be true, and its final leg from the what? Shipment table must be equal to true as well. Okay? So remember to ask questions where you are not clear. So we are grouping by vendor ID from the vendor table. We are grouping by what? Also vendor name from the what? The vendor table. We are also grouping by the service level agreement from the what? The vendor table. So now let's look at the final select here. So we are using the select to display our results, okay? Select vendor name, contracted service level agreement, total shipment, late shipment. So ask yourself, where are these column names coming from? Remember the aliases we have used so far in the code, right? Or in our queries. We have contracted service level agreement here as an alias. We have total shipment as an alias. We have late shipment as the alias here, and total penalties as the alias we want to show in our output, isn't it? So that is why we are selecting them. Here, we are calculating the percent of deliveries that were late. Secondly, here, we are rounding our actual performance into 2 decimal places and presenting it as what? On-time percentage, just to show how often they meet deadline. The third here, we are subtracting actual performance from contracted service level agreement, rounding it up to 2 decimal places, and presenting it as what? Service level agreement variance, okay? As well as total penalty. So for the total penalties, we are getting what? Total fine paid during this period. So let's look at the penalty estimate for future planning, just for future planning purposes. So we will multiply late shipments by the average of penalty amounts from the penalties table, and we'll round that up to 2 decimal places and present it in our new table as estimated future penalty. Then let's look at our performance rating. We are going to rate performance into 4, right? In the case when actual performance is greater than or equal to contracted service level agreement, then let us now say it meets what? SLA, okay? Because our contracted service level agreement is like what? A benchmark, okay? So when we have our actual performance greater than that, we will say, okay, definitely it meets our service level agreement. When actual performance is greater than or equal to contracted service level agreement minus 5, then we'll say it's a minor miss. When it's greater than or equal to contracted service level agreement minus 10, then it's a major miss. If it's greater than 10, we'll have what? Critical failure. So we will end this as what? performance rating, okay? And all these is coming from what? From our vendor performance table. Are you seeing that? That is a table. This table we are creating with the CTE we're using with to create. So we are ordering by what? Service level agreement variance in descending order. Okay. Let us execute this and see what we get. Then I recommend that you listen to this, put it side by side with the queries, understand it clearly, and where you have any issues, ask questions. Okay. But make sure you look at it and understand it very well. So let us execute this, and then we will see what we have. We have our vendor name, right? Then our contracted service level agreements, our total shipment, our late shipments, our late percentage, on time percentage, as we have calculated from the queries. We have our service level agreement variance, our total penalty, our estimated future penalty, and what? Our performance rating. You see that the performance rating of all of these vendors are on critical failure. And you see why that is. This gives stakeholders a clear picture as to what is going on and to answer their questions as to where the critical failures are coming from. Okay? Let us head on to the second, which will be a root cause analysis or a root cause investigation of the issues experienced by our clients. Okay? So let us look at this. We are already written this query here. And let's take it and explain it further. Okay. So we said is what? The root cause investigation, a CTE, that is a common table expression called penalty analysis. Okay. So, and this table, we'll be selecting the vendor name from our vendor table, the reason code from our penalties table, and our penalty reason from what? The penalty table. Then we are counting how many times the penalty reasons showed up and presenting that count as what? As occurrence count. And that occurrence count will give it a label so we can use that column later. So let's go to this line. So this adds up all the money lost due to what? Penalty type. Okay. We have penalty amounts from our penalty table. We are summing this, right? And presenting this as what? Total penalty cost. Now, we are here calculating the average of the penalty amount, rounding it up to 2 decimals, and presenting it as what? The average penalty. So let us calculate the percentage of vendors' total penalty. So we use the sum of the total penalty amount multiplied by 100, divide by the sum of the penalty amount over, then we are partitioning by what? By vendor's name from the vendor's table and presenting this result as what? Percentage of vendor's penalty. So let's go to this rank reason by cost. So we here, we are saying for each vendor, and that's why we use partition by what? Vendor name, right? So we are saying for each vendor, rank their reason from most expensive to the least expensive. That is what we mean here. And we want to present the result in a new column called rank reason, okay? So that is what we mean by this. And we are getting all of these from what? From the penalties table and with the alias. See, this highlighted query here connects 3 tables: the penalties tables, the shipment table, and the what? The vendors table. We are now saying where we only want penalties from what? 2023, the 15th of November 2023, and what? The 31st of December 2023. So we are looking at the holiday season. And we want where we have the holidays flag is equal to true as well. So this ensures we are only studying the holiday specific issue. Here we are now grouping by the vendor's name from the vendors table, the reason code from the penalty table, and the penalty reason from what? The penalty table. This last aspect here will be our final selection from the CTE. Remember when we were talking about the query previously, I made mention that columns here are columns we had created using aliases from our CTEs above. So we are selecting what we are going to see in our output will be the vendor's name, reason code, penalty reasons, occurrence count, total penalty count, average penalty, and percentage of vendor's penalty. And all of this is from our penalty analysis, this CTE that we are creating. And we are going to be ordering by vendor name and total penalty cost in descending order. So that is what this is, okay? So let us highlight and execute these, okay? We execute and we have exactly that. So we have our vendor name, our reason code, okay? If you look at this, select what we want to see. We have our penalty reason, we have our occurrence count, we have our total penalty cost, our average penalty, then our percentage vendor penalty. Then priority level that we added with our case when, okay? See, we now have critical and we have others. Now remember, we say when reason rank is what? Less than or equal to 3. So we already know that it is critical here because reason rank is what? Less than or equal to 3. So where we have others, basically the other condition, apart from where we have reason rank less than or equal to 3, that is what happened here. I hope that is clear. So now let's go to the last and final analysis we'll be doing concerning this issue. Let's go on to the final analysis and let's get the query. We'll be looking at the geographic hotspots. Let's paste this and as usual, talk about it. So we already know what select will do for us. And we had talked about what police means and why we use it. So, but here it's kind of different from how we applied it in the other instance. In fact, I'll say similar, but there we used what 0, and 0 was returned or was used as a value and not a text in that occasion. So here we are saying if the origin region is missing, that is, if it's null, label it as all region. And as usual, I think by now we should know what aliases means for columns, right? So we are going to be returning that in a column called origin region. So we are doing the same thing for destination region as well. If it's null, instead of returning null, return all regions. And let us use that or have that result in our output as what? Destination region. We are counting how many shipments were made for each origin destination pair. Okay? That is what is happening here. Then here, I already explained this in details. So we are presenting that as late shipments, okay? So from our explanations, we must have gotten used to what this will do because we have repeated it over and over using something or a sequence like this, even in our previous class. So we are summing here penalty amount from our penalty table and presenting it as what? Total penalties. And this is coming from what? From our shipments table. Okay. So let's look at this join section now. So the left join here extracts the first 3 digits of the origin zip to group by region. This block of condition here only include deliveries that were supposed to happen during the holiday season. The date can tell. I've already explained these in the queries above. And here as well, where holiday flag is true. Okay, so it only looks at shipments that are marked as holiday rated or rated as holidays. And we are ordering by what? Late percentages in descending orders. So we want to show the worst performing routes first. That is, will be the highest percentage of delays. Okay, that is why we are ordering by what? Descending order. So let us highlight and execute. All right, so now we have our outputs. And with these, we can know the what? Geographic what? Hotspot for poor performance. Okay, you can see our late percentage as we ordered in descending order. We can have the worst performing areas. Okay, or areas where we have the worst routes. To connect our Postgres to Power BI, we have several ways we could do that. We could connect our table directly, that is our database directly to Power BI, but that will mean that we will recreate everything we have done here, right, using that, and we don't want to do that. The second option will be to copy all of these queries we have written, that is for vendor performance, and connect using that so that we have these temporary tables we had created connected to Power BI. But again, is not an efficient way to do that. So we are going to be using views. That is, we will wrap all of these queries, that is individually, in or with what we call views, so that we can easily connect those views to Power BI and use them for our key performance indicators visualization. So to wrap each of these as views, I'm going to begin with the vendor performance scoring. And I'm going to say create or replace view. And that view, I will call vendor performance summary. Since this is vendor performance scoring, right? I'll say vendor performance summary. Okay, and I'll say as. So this wraps as a view, right? So everything within this will be wrapped as that view. So let us execute this, okay? So we have executed that. You see our view. Remember what we called this view, vendor performance summary, right? So let's look at that view. We'll say select all from vendor performance summary, okay? Let's take a look to make sure that is it, vendor performance summary, okay? Let's look at that. So now we have created this view, vendor performance summary, okay? All right, so let's repeat the same process for all other queries. We'll do that for root cause analysis here, or root cause investigation rather. So we'll say create or replace view, all this view, root cause summary. I will say as. Okay, so let us execute this. Let's take a look at that view. Say select all from, we called it what? Root cause summary, right? Root cause summary. Okay, let's execute this and look at that. Okay, we say root cause summary, isn't it? Okay, root cause summary. Okay, let's execute this now. Okay, we have that now. Then for geographic hotspot, the same thing. Say create or replace view. We are calling this view geo route summary. Okay, as let's execute this. Let's look at that view. Okay. So this is it now. All right, so let us open our Power BI and connect our Power BI to Postgres, okay? So you can search for Power BI and click to open Power BI. All right, we have Power BI opened. So from here, let us click on get data from other sources so that we go into Power BI fully. Now we want to search for our Postgres database, right? So you either scroll through, find it here, or search for it here. Okay, we have it here already. So I'll just click on connect, begin the connection process, or just on the Postgres database. So we have a PostgreSQL database connector. Now we have to enter the server as well as the database. You created a database while we're working on this, right? And we called it logistics DB, right? Okay. So the server name, since we have it hosted on our local device, will be localhost, okay? And remember, our port name while we were installing this Postgres was 5432, right? Our database name is logisticdb. So we have two ways we can connect. We have the import and the direct query. For the import, we will be importing tables directly from SQL into Power BI. For the direct query option here, we'll be writing our direct queries here. What is the difference? The difference here between import and direct query is that direct query kinds of have a direct connection, right? So whatever happens to the database reflects on Power BI without necessarily refreshing any connection. But in the import case, you have to refresh your connection to get changes applied, okay? So we want to use the import. Remember, we had created views, right, of all our CTEs that we created. So it is those views we want to import directly here to Power BI. We go ahead and then click on OK. When we click on OK, we are prompted to enter the username. The username here is Postgres, okay? Then the password is the password you used while setting up your pgadmin. Remember that, right? So make sure you remember that password. So I'm going to insert that password and then click on connect. Okay, this is just for encryption support. So let me read it. We were unable to connect the data source using an encrypted connection. To access this data source using an unencrypted connection, click OK. So we are going to click OK. So our connection is being established. The navigator view here, you can see our tables, right? We had the penalty table, we had the shipments, the vendor capacity, and the vendors table. Instead of us bringing this table into Power BI and repeating everything we had done in Postgres, we will just do what? Create views from the queries we had written, right? And remember this, when we created this or we wrote these queries for vendor performance, we use this part of it to create what? A view called what? Vendor performance summary. So we did for others as well. For root cause investigation, we created a view called what? Root cause summary. We also created a view for geographic hotspot or geo route summary. You can see this here, okay? If you go to our table, you'll see our original table. We had already done so much. So now we wouldn't take it, right? So we'll just check the views that we created. We created 3 views. You can see each of them. When you click on each of them, you're going to see the summary or the results preview. This is for the root cause summary, okay? And this is for the vendor performance summary. Let's go ahead and load all 3 of these to Power BI. And remember, you can see that all of these is from our logistics database, right? So let's load. Okay, it's loading. All right. Now you see immediately this turned to build visuals with your data. If you go to the table view, you are now going to see the tables that we imported, tables we imported as views, right? So that we could import those CTEs as tables into Power BI, okay? So this is for the route summary, this is for the root cause summary, and this is for the performance summary, okay? So we go back, build our visual. Now, I want to point out something. Not all dashboards basically are dynamic. What makes dashboard dynamic? They are dynamic because we can slice through them using what? Or filter through them using filters, okay? All right. So now, if we look at these, going back to the table view, you see that we just have values or views that can be presented in a static dashboard. We also should remember that our analysis is centered strictly within a specific period in time. So viewing or slicing through or filtering through sometimes will not give us the result that we want. Remember, we worked in a particular year, which was 2023. We looked at the holiday season, and the holiday season was just within what? 2 months. We basically have the result that we want within that time frame. So if you go and pick May, you see that your dashboard will become flat. You will not have anything to view on your dashboard anymore. And if you look at our vendor's name, for instance, in this vendor performance summary, see we just have 3 vendors, which we can easily view at once. When you look at our root cause summary, you see that we just have about the same vendors, okay? And our priority level are just about critical and order, just 2 priority levels. So this should inform you about what to do. Imagine us slicing between priority levels or using priority levels as our filter. What will happen is that we are either looking at critical or order. So you can imagine that, right? If you look at our root or geo root summary, you see we just have something that we can view comfortably in a static dashboard. So it depends, okay? When you have lots of data to be presented in a dashboard, that is when you begin to look at the dynamic nature of a dashboard, because you want to cut through regions, you want to cut through seasons, you want to cut through time, right? So that is what makes dynamic dashboard dynamic, okay? I say it again to reiterate, the dynamic nature of a dashboard will be lost if you cut through a time when there is no data to be presented. You get that, right? Okay. So even if we have clean views as we have now, we still need some tweaks, right? We still need to make some adjustments to be able to use them for our dashboards, okay? The first we'll be dealing with is to add friendly labels in root cause summary. Let's look at that root cause summary and see why we have to do so. For instance, in this root cause summary view, we have what? We have reason code and we have penalty reason as well, okay? So what we want to do now is to show vendors penalty. So we have to put these 2 columns together. That is the reason code and penalty reason. And to do so, we will have to create a new column for this table, okay? So we can go to table tools, all right? So here in column tools, we can just do what? Click on new column. And mind you, the reason we have column tools is because we clicked on that column, right? That column was highlighted. You can also still add new column within table tools. Under calculations, you can see new column, right? So in column 2, under calculations, you can see new column, okay? It's the same thing, right? So let's click on new column now, okay? So now in the formula bar here, we can enter the following formula. Our column now will be called what? Reason details, okay? That reason details will just basically concatenate the reason code and the penalty reason. That is, join them together separated by what column. So let us do this. So we'll say equal. In square brackets, we can now find the what? The column headers here when we open square brackets. And we are talking about reason code, right? The reason code first. Then we'll say and, open quote. Let's put in the column, close quote, to say and again. Now we can safely open square brackets to put in the penalty reason, okay? So once this is done, we can hit enter. Now you can see what we have here. So if you look at this now, we have the reason details, and in the reason details, we have the reason code and the what? Penalty reasons. If you want to put a space before this, you can go ahead and add that space, hit enter again, and you can see we have the space, okay? So let us now create geographic subtables. Let's go to the table tools and say new table, right? We'll click on new table, then we can begin creating our table. So we want to call this table origin. Okay, we'll say origin equals, or let's call it origin performance, right? So say origin performance equals, we use filter, open parentheses. Now let's refer to the table geo route summary, right? This is it, okay, comma. Now we want to refer to the destination region in that geo route summary table. So we will refer to the table, okay, so say geo route. Now, when we write it, because it satisfies that part of the syntax, you can see we have the table, then what? Columns of the table. That is what we want to do. So we want to pick destination region, okay? And when we do this, we want to filter this for all regions, okay? Remember, we have all regions there, and then we close our parentheses. So we'll have this in double quotes rather, okay? All right. When we hit enter, it's going to create a new subtable. So it has created a new subtable, a destination region for all regions. So in the origin performance table here, or let me use subtable so that you remember that we created these from our geo route summary. We have filtered destination region to be all region. So let us create the destination focus table now from our geo route summary, okay? So as usual, we want to create a new table, okay? And we'll call this destination performance, okay? We'll say equals, we'll say we use filter, open parentheses. Let's begin to type geo route and we will get that table name, comma. We want to filter the origin region from that geo route summary table, right? So we will say geo route summary. So you can see it here. We want this column from that table, and we want to filter all regions, okay? Close the parentheses, close the quote, rather, close the parentheses, okay? So we hit enter to get that table. Now you can see why this is destination focused, while our origin performance table here is what is origin focused, okay? So in the model view here, you can see the subtables we created, as well as our views we imported. Okay. You can see this is very important that we have a one-to-many relationship here between our vendor performance summary table and our root cause summary table. And the relationship is between vendor name, right, and vendor name. Okay, that is vendor name from the vendor performance summary table connected to vendor name in the root cause summary table. So let us go on to create key metrics. That is, we'll be creating measures. We want to create the first measure in the vendor performance table. And to create measure, we will have to head back to what our table view. And we want to create that measure in our vendor performance summary table, right? This is the table, our vendor performance summary table. So we want to create a measure called total penalty, all right? So we can click on new measure under calculations in table tools here. Let's click on new measures, okay, to calculate that measure. So this measure will be called total performance, right? I'll say total performance equals, we want to sum the total penalties, right, from the vendor performance summary table, okay? Let me take this out so that you see what I mean. You can see total penalties here, right? So we want to sum it so that we can easily use that measure in a card when we are creating our dashboard, okay? So let's say sum, okay? And remember, what we do when we want to sum a specific column within a table, we reference the table, then that column. And that table is what? Vendor performance. So if we just type vendor performance, as we type on, you see the table and you also see the title of the columns you will want to sum. Okay, so we want to sum total penalties, right? So we have it here, vendor performance, then we have total penalties. So we close the parentheses here and hit enter. We will have created that measure called what? Total performance. Rather, total penalties. Instead of total performance, let's have total penalties, okay? So you can edit that and still hit enter. You will have edited it and calculated the total penalties measure, all right? So the next measure we are going to be creating under this table is the critical vendor count. That is, what we mean is to count vendors with what? Critical failure, okay? So we will go to table tools and click on new measures. Then let's call it critical vendor count. We'll say equals. We want to count rows, so we use the function count rows. Open parentheses, filter, open parentheses. We want to filter our vendor performance summary table. So we'll say vendor performance summary table. We get that in there. We'll say comma. So say vendor performance summary, that is, we are counting what? The performance rating, okay? That's what we are counting. That is, we are counting the performance rating column, this column, okay? And that is from the vendor performance summary table, right? So we want performance rating. Then we want it to strictly count the critical failure. Then we close the quote and close two parentheses, one for the filter, the other for count rows, okay? Then hit enter, we'll have counted that. So we have the critical vendor count. So that is good to go. If for any reason you want to rename, remember how we did for the total penalties when we mistakenly wrote total performance instead of total penalties. Okay, so we have done that critical vendor count, correct. So the next measure will be under the root cause summary table. And we want to identify critical issues under the root cause summary table, okay, where we have critical. So if you go to that root cause summary table, you will see what we mean. Under the priority level here, you see we have critical as well as others. Okay, look at the filter. We have critical as well as others. So we want to focus on the critical instead of the others. The critical is what is of importance to us. All right, so let us add that new measure, okay? Under table tools, we click on new measure. We want to call that new measure critical issues. So the critical issues equals, use the function calculate. We had discussed in our previous classes about the function calculate. So say calculate, open parentheses. We want to count rows, open parentheses. We are counting rows from the root cause summary table, right? Okay, so we have it here. Then we will close parentheses, take comma. So our interest is in the priority level column of the root cause summary table, and we are interested in the critical output, right? Okay. So say root cause, it's here, root cause summary, and I think we have that column here, priority level. So we'll click to enter. So we want to say priority level equals to, that is our interest. Open quote, the critical, okay, close quote. Then go ahead and close our parentheses. So this would help us in ensuring that we have that measure that counts what the critical issues. So we just basically want to know how many critical issues that we have, okay? In our origin performance table, we will also want to enter a measure, create a measure, and the measure will be to calculate maximum origin lateness in percentage. Okay, so let us know that. Okay, so let's go on to do that. That is origin performance. You remember that stop table we created from our geo summary, right? This one. Okay, so let's say new measure, and we will calculate the measure called max origin late. Okay, we'll say equals. We'll use the max function, open parentheses. Our table of reference is the origin performance, right? To say origin performance, that is it. Say command. Column of interest is this late percentage. This late percentage is a column of interest. So sorry about that. Let's take that out. It's not complete yet. So we'll say comma. So we want to reference this same origin performance table, but late percentage is what of interest to us. So go ahead and close parentheses. With this now, our syntax is complete, and we hit enter to calculate that measure, max origin. Let us correct this, please. So it is max origin instead. Okay, max origin leads. Hit enter to get that. Okay, we have corrected it. So we have created all of our measures, basically worked on our data to make it more presentable when we work on visuals. So let's go into the visual creation now. So if you look at it carefully, we had vendor overview, we have root cause analysis, and we have geographic hotspot. These are the three things that we've done. So it is possible that we create 3 pages of visualization, right? So you can also put all of these visuals together. That is, if you want to create something like, say, a summary visual where at a glance, stakeholders can understand what you're presenting. But it's also great that you break them into teams, right? You break your presentation into teams so that you can present them properly or communicate them properly without any confusion. Okay. So that is to say that as we go to our report view, we can have 3 pages of what? Of reports. Page one will be the vendor overview. Okay. So we'll call the page one vendor overview. Okay. Then the page 2, call it root cause analysis. Then the page 3 will be geographic hotspot. All right. So now we can just create simple visual to bring our analysis to light. Okay. All right. So let's start with the vendor overview. The goal here is to give a quick snapshot of vendor performance. So we are going to be using KPI cards. We'll be using table and bar charts as well. Okay. Just simple chart. So we are going to start with the KPI cards, or let's just insert cards basically. So that will show our key performance indicators. We have KPI cards here. They are different from the cards here. So we are just going to insert card. All right. So we are going to take total shipments, right, to the data field, or you can just check it and you have the total shipments. Okay. So we have created that card for total shipments. We'll see how we can quickly present this instead of us having some of total shipments, we just have total shipments. Okay. So for now, let us go on to add another card. Okay. So add another card. Let's take this card to the side here. And that card, we are going to have total penalties displayed in that card. Okay. You can see total penalties here. Let us check that we have total penalties. Remember what I said about sum of total penalties, right? So let us create the third card. Okay, so the third card will be critical vendor count. Remember when we added these measures, right? Just not long ago. So let us add that card, okay, and we move it to the side. So that card is going to be what for our critical vendor count. Okay, so the critical vendor count was added under this vendor performance table, right? So let's check it. We'll now have our critical vendor count. So it's clear that we have 3 counts for critical vendor count, right? So you can see how we are gradually bringing our data to life. Okay, so now remember I said we have 3 elements, the KPI cards, that is the cards that showcase our KPI. I clarified that. Then bar charts and our table. So let us insert our bar charts first. So let us insert this clustered bar chart. So we can pick vendor name to the y-axis, then SLA variance to the x-axis. Okay, so we have that visual now. You can adjust as you like. So we will be able to create the table here. So to create the table or to insert the table, we are going to do what? We are going to insert the table. So click on table to insert the table. So we'll have the table here. In the table, these are the various fields we want. We want the vendor name, okay? We want the vendor name in the table, all right? Okay. We also want on-time percentage, okay? Is on-time percentage, right? We also want SLA variance, okay? Let's adjust. We want SLA variance and we also want performance rating. Okay, so this is what we have in the table. We can adjust very well. Okay, so mind you, this is just showing you, bringing our dashboard to life. We are not yet dealing with Power BI per se. So in the next week or in the next class, we'll be going into Power BI more. Okay, so now it's just a way to show us, okay, this is what we can do with our visuals and we can bring our visuals to life. Okay, so we'll not really be designing much, okay, apart from entering our visuals, okay? All right. So now as it is, I want to point out something. It is possible that as you do your designs, you come to view and you can see teams, right? You can pick from various teams here to use, okay? So now you can see the vendor overview. You can see the sum of total shipments. You can see the total penalties, right? And you can see the critical vendor count. even from the clustered bar chart, you can see the vendors that we are looking at. That is JetRush, Couriers, Northstar Logistics, and QuickTrack Inc. Okay, you can basically see them. And remember the objective or the goal of our analysis in the first place. We wanted to look for the vendors that are costing us or our clients that much monies in penalties. Okay, to remember that and apply that. So we are basically seeing this overview, but there's something I wanted to add. Basically, remember I said we could edit the labels here. So when you click on any visual, you come to visualization, you have three important, I'll call them tabs, right? We have build visual, we have format your visual, and we have the add further analysis to your visual. So under format your visuals, we can basically edit our visuals, that is, edit the call out values, right? Then we can also put on and off the category label. Under general now, you see we have title. If you put on the title, you are going to, let's insert the title. And the title, if we call this title total shipments, okay, you can see the title here, right? So you can decide to work with the title or you decide to work with the label. Okay. So you can work on this to adjust as you like. Let's put that off. Let's go back to visual and the category label. You can change the font and whatever color of the category label. Okay. Okay. So that is how that is done. Okay. So in the page 2, we basically talked about root cause analysis, right? And the goal here is to understand why penalties are happening. Okay. So we will be using a pie chart, a tree map, and a stacked bar chart. All right. So let's start with the pie chart. In the pie chart, we will be creating priority level versus critical issues. So let's insert a pie chart. Okay. So we are going to take priority level. Let's take it to the legend here. Then critical issues, we'll put them in values, okay? So let's take critical issues, the major critical issues we created and put them here. So we get this, okay? So the next that we are to insert is the tree map. So we click somewhere inside here so that it doesn't change our selection. Click to insert tree map. So in the tree map, we want to drag reason detail. Remember the reason detail we added, okay? This reason detail, we combined penalty reason and reason code. So we are going to take reason details into the category field. Let's take reason detail into category. Then we are going to move total penalty cost into the values field. This total penalties, let's move it into the values. Then we have our tree map, okay? So the next for this root cause analysis that I'll be inserting is the bar chart. So the bar chart, we will look at vendor name versus total penalty cost, okay? So let's insert this bar chart. We'll put the vendor name. So let's take vendor name to y-axis, and then we'll put total penalty cost in the x-axis. Let's put this in the x-axis. Okay. We use priority as the legend. Okay. Let's look at priority level as the legend. Okay. So this gives stakeholder a clear picture of what our analysis is. Okay. Instead of just the queries and the DAX we had written, we have a visualization to back them up. Okay. Remember, this is basically like an intro to visualization. Okay. All right. So let's go to the geographic hotspot. So here under the geographic hotspot or in the geographic hotspot page, our goal is to spot where shipping problems are happening based on the geography, say our origin destination. Remember, the origin and destination tables we created from our geo summary table, right? We are going to have the cards to showcase our KPI. Then we are going to also have a matrix visual. We insert that card, okay? Now in the card, we want to look at the max origin late percentage. Remember that we created, okay? So I think it was under this table, max origin. So let's take that here. We can have it now as that, okay? So what this shows is that it shows the highest late delivery percentage among all origin regions. So let's enter the second element, which is the matrix visual, okay? So we insert the matrix visual, this, okay? Now in the matrix visual, we want to use origin as the rows, okay? That is origin region. I think we have that here as the rows, okay? Then for the columns, we are going to use destination region, okay? This for the column, okay? And for the values, we are going to use delete percentage, okay? So this goes to value. All right. This is powerful because it makes it easy for logistics managers to spot risky routes, okay? You can quickly focus on fixing those routes. Remember how these were gotten, right? They were gotten from region zip as the first three numbers in that region zip, okay? Remember how we did that in SQL, okay? We have basically looked at our analysis in a view that will help us understand better and help us communicate better. And that is what dashboard visualizations are about. This is not a production grade visualization. However, it gives image to what we have created and is a great first step to beginning visualization, okay? So as a challenge, you can put all of these in a single dashboard, and I would like to see how your single dashboard will look like, where we have the vendor overview, the root cause analysis, and geographic hotspot, okay? You can create all of these in one single dashboard, and that is what I'll be expecting of you. Put them all in one dashboard. Let's see how you will manage that and mentor you accordingly, okay? To have a blessed day ahead.